Section 4.5, the greatest common factor and factoring by grouping. So 4.5, the homework is divided into two sections, 4.5a and 4.5b. 4.5a will be the first three videos of these four, and 4.5b will be the fourth video. In the first three, we'll talk about the greatest common factor and how to factor out the greatest common factor, and I'll show you what that means. And of course, the fourth video is factoring by grouping, which is basically factoring out the greatest common factor 3 times, and you'll see that when we get to it. Okay, so what does factoring mean? To factor means to write an expression as a product or quotient. Okay, write as a product or quotient, as opposed to a sum or difference. Okay, now why would we want to do this? We like to do this because the rules for multiplication and division in algebra are simpler than the rules for addition and subtraction. A lot of people think it's the opposite just because they learned addition and subtraction first and multiplication and division second. They think that the addition and subtraction is easier, but that may be in arithmetic, but not in algebra. It's the other way around. And I have 3 examples for you. The first, AB over CB equals A over C. It's a very nice simplification rule for products and quotients. But A plus B over C plus B has no rule for simplifying at all. So, the multiplication has this advantage. You can't cancel it. You can cancel a factor of the numerator with a factor of the denominator, but you can't cancel a term of the numerator with a term of the denominator. Okay, here's a second example. A times B, the quantity to the 7th power, equals A to the 7th power times B to the 7th power. And A over B to the 7th power equals A to the 7th power over B to the 7th power. But A plus B, or even A minus B raised to the 7th power, has no rule for simplifying. It has a rule for multiplying it out, called the binomial formula, but that gives you 8 terms, which is not simpler than the way it's written now. So there's no rule for simplifying it. But there is if you were multiplying or dividing, or not necessarily simplifying, but writing in a slightly different form that may be more useful for you, depending on what you're doing. And remember, these identities here, these are called identities, they go either way. You go right to left or left to right. So you can change the form real easily. But this thing here, you try to change the form, you're multiplying this thing out, and you end up with a full 8 terms. It's kind of complicated looking, and you need a really good reason to want to do that. We usually prefer to have it in this form because this is actually the factored form. Here's another reason, and this comes up quite a lot. If A times B equals 0, then A equals 0 or B equals 0. There's no similar rule for A plus B equals 0. Now you might think, oh, but A plus B equals 0 means that A equals the opposite of B. Well, yeah, that's true, and that's some information, right? And sometimes that might be useful, but it's not a specific number unless you know what B is, which you usually don't. So the A, B equals 0, well, I shouldn't say you usually don't. You often do. But in this situation where I just have A and B, and I don't know what A and B are, the fact that their sum equals 0 does not tell me what A is. Whereas in the first one, A times B equals 0, A isn't necessarily 0, but either A is 0 or B is 0, right? Which is pretty good, and it helps us to solve equations frequently. Okay, so in a factoring example, I'm just doing this with integers, so you can see that this is actually working. Of course, you know, if I gave you 10 minus 4, you would just write down 6, right? So you wouldn't need to factor it. But this is, remember when you have variables, underneath those variables are numbers, right? And behind the variable is a real number. So, you know, they work the same way. So you got 10 minus 4 equals 2 times the quantity 5 minus 2. Now you can check this by just going right to left, which is the distributive property. If you take the 2 times 5, you get 10. 2 times negative 2 is negative 4. So you can see this is correct. And you can even, you know, calculate them. The 10 minus 4 is 6. 5 minus 2 is 3. Multiply that by 2, you get 6, right? Anyways, but this is what factoring is. You're writing it. You're taking this thing on the left and writing it like on the right. And what happened here is the greatest common factor here is 2. So I wrote down the greatest common factor, and then I took these two and divided each of them by 2 and wrote the result here. 10 over 2 is 5. Negative 4 over 2 is negative 2.